Hello, what I'm going to do is review trig stuff from chapter 1, so I'll give you a brief overview. We're going to do some conversions between radians, degrees, plot some reference angles, look at coterminal angles, and then we'll plot a point and take a look at the 6 trigonometric functions, followed by evaluating trig functions, and then go on to some right triangle trig problems, story problem applications, solving right triangles, and then finding exact values of trig functions. So I'll get started with the first question. So taking a look at these, we want to graph each angle. So in this first one, we have negative 2/3 pi. So again, pi being 180 degrees. If I were to go negative 2/3 the way, so going clockwise, 2/3 of the way would take me to about here, since 2/3 of 180 is 120. So we're going to be going this way. So if I were to first convert this, that is negative 120 degrees. We could also obtain that from taking 2 pi over 3 times 180 over pi. And if you simplify this out, it's going to end up coming out to 120. So that's the first thing, is just to draw and sketch the triangle, which is in the third quadrant. The next thing is to determine the reference angle. So we want to take a look. If I'm already 120 of the way, to get to 180, I need 60 more degrees. So therefore, my reference angle is 60. And then the last thing is to find my one positive and my one negative coterminal angle. So I'll do the positive one first, which says basically if I were to go this way, how can I get that same terminal side? Well, if I went 180 degrees and I added another 60 degrees from the reference, that would give me a positive coterminal angle of 240 degrees. If I go the other way, though, and I go a full lap around clockwise, that's 360, plus that another 120, that gives me a negative coterminal angle of negative 480 degrees. So those are the coterminal angles, and I did the other parts. All right, next one, taking a look at 110 degrees. First thing I'm going to do is sketch that. So that'd be like going 90 plus an additional 20, so I'm going to stop here, put my terminal side up there, create my triangle. So first thing, that is in quadrant 2. I'm going to convert this by multiplying the 110 by pi over 180. If you simplify this, it's going to come out to basically your zeros just knock off here. 11 pi over 18 radians. So that's my conversion. And then we'll take a look at the other stuff. So basically, if this went 110, my reference angle is telling me how much more I would need to get to 180. So if I take 180 minus the 110, I get a reference angle of 70 degrees. And then I'll look at my coterminal angles. First one now I'll look at is the negative. So if I were to go the negative 180 and another negative 70, that gives me my first coterminal angle of negative 250 degrees. And then if I were to do the same thing that I did in the last example and go counterclockwise, a full 360 plus the 110, so 360 plus 110 would give me a positive coterminal angle of 470 degrees. All right, taking a look next at a trigonometric function, a point, and naming the trig function. So I'm going to first plot negative 3, negative 6, which is going to be down here somewhere. So I know that that's the terminal side of some angle, and I really don't care what the angle is. What I want to do is label. So this would represent my negative 3, because that's the x part of the coordinate. This would represent my negative 6 for the y. First thing I'm going to do is Pythagorean theorem and figure out my third side, which I'll just label that as c. And it's going to end up being 9 plus 36 is c squared. C squared equals 45. So c is going to be the square root of 45, which if I extract my perfect square of 9, that's going to go into 45 5 times. And the square root of 9 is 3. So my c value over here on the hypotenuse is 3 radical 5. And that is a positive value since it's the negative square that's going to become positive. So now what I'm going to do is look at my 6 trig values. So I'm going to have a sine of this angle, which I'll just call my angle x. I'll have a cosine of it. I'll have a tangent. And then my reciprocal functions, which for sine, the reciprocal is cosecant. For cosine, it's secant. And then for tangent, it's cotangent. All right. So I'll take a look at these. Again, this would be my reference angle that we're talking about. I'll start off with an easy one. I'll do tangent right away, which is opposite over adjacent. So if I were to take my -6 over -3, that's going to end up being 6 over 3, which is +2 then, because it's a negative over negative. So that's my tangent. My cotangent would be the reciprocal. So again, as a number, whole number, 2 is really over 1. So if I were to flip that fraction, I'd get my reciprocal, which is a cotangent of 1/2. I'll take a look at cosine, which would be taking my adjacent over my hypotenuse. So if I take -3 over 3 radical 5, first thing, 3's cancel. I'm going to replace the top one with a -1, but then I need to rationalize that. So I'm going to multiply my numerator and denominator by radical 5. -1 times radical 5 is negative radical 5. My denominator is going to come out to just 5. So that is my cosine, which instead of taking the reciprocal and re-rationalizing, what I can do is just go back to the diagram and I can say, okay, instead of taking opposite over adjacent, what if I take adjacent over opposite? Okay, why did I just, okay, oh wait, instead of taking adjacent over hypotenuse, I'm going to take hypotenuse over adjacent. Blah, got it right. So if I take my adjacent over my hypotenuse, I'm going to take 3 radical 5 over negative radical 3. 3's are going to cancel out here, and I will end up with negative radical 5. So that is my secant value. And then lastly, to get my sine ratio, I'm going to take the ratio of my opposite side, which is -6, over my hypotenuse, which is 3 radical 5. This will look similar to what we did before with cosine. Simplify the -6 over 3, which is -2. Radical 5 stays in the denominator, and then I just have to rationalize it. So I'm going to end up with my sine of x being -2 radical 5 over 5. And then just like we did with cosine, I'm going to end up taking the ratio of hypotenuse over opposite. So just basically flipping that. So I'm going to end up with 3 radical 5 over -6, which the 3 over the -6, I'm going to leave as negative radical 5 over 2. So 3 over 6 being 1 over 2. And those are my 6 trig functions. So then we'll go on to exact value. So the first thing I'm going to do is sketch a reference angle here. We'll determine the measure of the reference angle, and then we'll evaluate the cosine of that angle. So first thing, since this is a negative, I'm going to go in the clockwise direction, and it is 3 pi over 4. So if I were to basically go 3/4 of the way over, I'm going to end up with a terminal side in my third quadrant, and then a reference angle. Since it's pi over 4, if I were to break my 180 up into 4, my reference angle would be a 45-degree angle. So that is 3/4 of the way there. The opposite side to 45 would be my negative radical 2 over 2. It's negative since I'm going below the axis. And my adjacent side here would be negative radical 2 over 2 as well. So the cosine value I'd be looking for is the one that's the adjacent side. It's the x-coordinate, which comes out to negative radical 2 over 2. In the next one, we're given the angle measure in degrees, so I'm going to sketch a 150-degree angle. If that's 150, my reference is 30. Across from the 30, I label this side as 1/2, and then my adjacent side, negative root 3 over 2. And what I want to do is figure out the cosecant. So cosecant is the reciprocal of sine, sine being the y-coordinate. So the sine would be a 1/2. So I can just say sine of 30 is a 1/2, and that is true. But I want the cosecant of that value, and that's going to end up being the reciprocal of that, which is 2. And then lastly, I'm going to do a tangent, and 5 pi over 6 would be if I went 5/6 of the way. So if you chopped your 180 up into 6 pieces, each piece would be 30. So it's going to be the same triangle as the last problem, except I want the tangent ratio. So I'm going to copy down those side lengths again that I had. Once again, tangent is taking your opposite over your adjacent. It would also be, again, if I express this as a coordinate, tangent is where you take the y over the x value, sine over cosine, opposite over adjacent, it's all the same thing. So I'm going to take 1/2 over negative root 3 over 2. 2's are going to cross out. I'm going to get 1 over negative root 3. I'm going to want to rationalize that, so multiply by radical 3 over radical 3. and my tangent ratio comes out to negative radical 3 over 3. Notice I'm just strapping that negative sign wherever I want. I can go in front of it, it could go to the top, or it could go to the bottom. So that's where the negative comes from, and then again 1 times radical 3 is the radical 3, and then my denominator is just 3. Alright, on to the next. So we have an application problem with right triangle trig. So I'm going to try to determine the value of x here. And I'm really just going to break this up into two triangles. So I'm going to look at, if I were to take the triangle that has the 56, which is the small one, and then I'm going to look at the larger triangle here, which has the 35 out in the corner. So what I'm going to do is label my 115 on both of my diagrams. I'm going to label this as 56. I'm going to label this as 35. So what I'm going to do is throw some letters out here. With this triangle where my cursor is, I'm going to call this letter Y, and I'll do the same thing on this diagram. And I'm going to call this ginormous side the letter Z, which would be Z on this diagram. So at the very end of the day, I can say, hey, x plus y equals z. That is a true statement. So we really want this x value. So what I'm going to do is subtract y on both sides. So I'm going to do two separate trig calculations here. In this first triangle, 56 is my reference angle. I'm given an opposite side, and I want to find my adjacent. That tells me I'm going to say tan 56 equals 115 over y. Therefore, y is equal to 115 over tan 56. And that ends up being a y value of 77.57. And I'll do the same thing in the bottom diagram as well. So I'm going to take my tangent of 35 degrees and set that equal to my opposite, which is 15, over my adjacent, which is z. This ginormous z distance is 164.24 units. So at the very end, we just want to subtract these two things. So z is this giant one, y is this little guy, so we want the x value. So I'm going to end up saying that x is equal to 164.24 minus 77.57, and that's going to give me an x value of 86.67 units. Alright, so a couple calculations in there. That's how this next problem is going to look as well. So I'll give you a sec to read over this. 12-foot ladder is positioned up against the building at a 71-degree angle. So I'm going to draw my little ladder in here, positioned up against the building at a 71-degree angle. The ladder itself is 12 feet. If the ladder is pulled back, so going this way, 1 foot horizontally from the base of the building, so we're basically going to increase this bottom distance by 1, and it wants to know how high up the wall it will be. So the first thing I'm going to need to do is basically figure out what this bottom distance is. So what I'm going to do is call this value x, and the first thing I'm going to do is say, okay, well, I need my adjacent side over my hypotenuse, so that tells me I'm going to be using cosine here. And what I'm going to do is say cosine 71 equals my adjacent over my hypotenuse. So x is going to come out to 12 times the cosine of 71, and that is 3.91 feet. So that is this side on the bottom. And what I'm going to do then, like I said, if we're moving this ladder 1 foot away from the wall, what I'm going to have to do is add 1 to this. So my ladder is now going to be positioned 4.91 feet from the building. So I'm going to redraw a triangle. That also changes my angle. What it doesn't change is the size of the ladder. At the end of the day, you're not chopping a foot off the ladder or adding a foot to the ladder. The ladder is still staying at 12 feet. The angle is different, but we actually don't care about the angle, because if I know 2 of the 3 sides of my right triangle, I can use the Pythagorean theorem and solve for that value. So what I'm going to do is say y squared plus 4.91 squared equals 12 squared. And in the calculator, what I'll do is take my 12 squared minus 4.91 squared, and then I'll square root that answer. So that ends up being y is 10.95 feet. So what that means is that at the very end of the day, after I slid this ladder back, it is 10.95 feet up the wall. just because I have the calculation handy. In this original diagram, the ladder was positioned 11.35 feet. So just know that you wouldn't just be able to subtract 1 from this just by adding 1 to this distance. I had to do all that work just to figure out how high the ladder was up the wall. Alright, next problem. Seems like I'm logically working backwards because this one's a little bit easier. We're going to go back to just some sine, cosine, tangent calculations. Solving the triangle below means I want to find my lowercase a, I want capital A, and I want my lowercase b. So, easy one is for me to take my a value, which, small angle in the corner, I already know I have a 60 and a 90. So all I really have to do is take 90 minus 60, since all my angles are going to add up to 180. I have a 90, a 90. I have a 90, a 60, and then my last one would be 30 degrees. If I want to find my b value, I can say, okay, the sine of my 60 degrees is my opposite to my hypotenuse. So sine 60 equals b over 50. So b is equal to 50 times the sine of 60. And that is going to come out to roughly 43.3 units. So that's what this b value is. If I want to figure out what a is, I have a few options. I can use the Pythagorean theorem and say a squared plus 43.3 squared equals 50 squared. I could use a as being my opposite side to this a and say, okay, sine of 30 equals a over 50. I could also say cosine of 60. So that would be taking a look at my reference of 60. And that is equal to my lowercase a over 50. Either way, a is going to come out to 25. So, the last thing that I wanted to mention is that in order to find this other value of angle A, instead of just adding them up and setting them equal to 180, what I could also do is say, okay, well, this is opposite, this is hypotenuse, so I could say sine of A equals 25 over 50, and then just take an inverse sine. So A is also equal to sine inverse 25 over 50, and that's going to give you the same thing of 30 degrees. So last problem, we're going to take a look at an exact value of some trig functions based off a couple constraints. First thing, I'm given that the secant of an angle, again secant is the reciprocal of cosine, the secant is negative root 2. So if the secant is negative root 2, what I want to do is take the reciprocal of this. And if I take the reciprocal, it's this. If I rationalize this, it's going to give me radical 2 over negative 2. So we want to think about where cosine is going to give me first a negative value, but we also want to think about what reference angle would yield a cosine value of negative root 2 over 2. So I'm going to first throw that over here because that's one of my other trig functions. So the cosine would be negative radical 2 over 2. So this already knocks out 2 of my 6 values. So what I want to do is think about where cosine is negative. Well, cosine is the x part of a coordinate. So cosine would be negative in the third quadrant. And then my x values are also negative in my second quadrant. So the reason there's restrictions on this, or a constraint, is we want to look where tangent is positive. Well, tangent, again, is when you take your y over your x. So that's either when you take a positive over a positive, or a negative over a negative, which would be in the third quadrant. So that tells me that my reference angle is in my third quadrant. I know that when I have a radical 2 over 2 for my x coordinate, that means that I have a 45-degree reference angle. That also means that my side that's opposite to that, especially because it's below the x-axis, that tells me it's going to be negative radical 2 over 2. So right away I can say, okay, my sine value is going to be this y-coordinate here, which is negative radical 2 over 2. I can also conclude then that my cosecant of x is going to be the reciprocal of this. Well, we already started with the reciprocal of this fraction. It was negative root 2. So the last thing I need to figure out is tangent. And again, that is where we take my y value over my x. So if I have a negative value divided by a negative value, that's itself. A negative value divided by itself is 1. And since it's a negative over a negative, it is positive 1. And my cotangent is the reciprocal. 1 over 1, which is 1. So with those types of problems, you want to sketch, first of all, figure out what quadrant your angle or angles could lie in, and then you apply the constraint. So with us, we had to look where tangent was greater than 0, and it is. The tangent came out to positive 1. And then from there, determine your reference angle, and then we can look at our remaining trig ratios. So just to quickly recap through all this stuff, we started off with graphing angles, identifying reference angles, doing some conversions, and then looking at coterminal angles. Kind of shifted a little bit to looking at 6 trigonometric functions. We did some evaluating with exact values, story problem applications, solving right triangles, and then finished with exact values and constraints.